word problems that we've been talking about. The first one we're going to be doing is a DIRT problem. Remember that DIRT's an acronym. It stands for distance equals rate times time. So that's the DIRT. And the second one we do is going to be a money and number problem, and we've done a few of those as well. And kind of coming in with you understanding how the chart works, but we'll help fill it in if we can. So the first problem we're going to do is number 29 in your book. And so we had Kelly, which was going 15 kilometers per hour. Jack was going 12 kilometers per hour. They leave the school at the same time in the same direction. How long will it take until Kelly is 18 kilometers ahead? So we're going to start, as we do with all of these, as drawing a diagram first. A diagram is super important because it helps me understand which type of DIRT problem I'm doing. So here we go. We have two people, and they're starting in the same spot. That's important. Okay, so here's school. And so then we have one person who we call the fast person. Okay, so that's the fast person. In this case, it's Kelly. So the fast person is going to go some distance that we don't know what that is quite yet, but we know it's some distance. And then we have a slow person. And in this one, it tells they leave school at the same time, going the same direction. So to show that this is the slow person, I'm going to have to make it so that the slow person doesn't go as far. Okay? And that's Jack. Okay. So now we're going to go and fill in the information that we have. So we know, and I'm going to always put the rate on top and the time on the bottom. Okay? Rate on top and time on the bottom. Rate on top and time on the bottom. So I know that the fast rate tells me that it's 15 kilometers per hour. So this is 15 km per hour. And the slow rate is Jack. That's 12 kilometers per hour. 12 kilometers per hour. Now, what they don't tell me, when I read the problem, is how long each person is traveling. So since they don't tell me how long each person is traveling, I don't know. But what I do know, I don't know how long that the fast person is traveling. But what I know is they start and stop at the exact same time. So if they start and stop at the same time, whatever this time is, this time also must be true. Or must be the same, excuse me. So the two times have got to be the same. And so the last thing that they tell me is that when they stop, the fast person, Kelly, is 18 kilometers further ahead than the slow person. So the way I look at that is that Kelly has an 18 kilometer gap. So this distance from here to here, if I want the slow person to catch up, I've got to give them that much of a head start. So this is 18 kilometers. And it's not kilometers per hour. It's not a rate. It's not time. It's a distance from here to here. So I wrote it in the middle. I didn't write it above the line. I didn't write it below the line. I wrote it right in between the lines. So it is 18 kilometers. Okay, that's how far of a head start the slow person would need. Okay, this is all the information that I need to set up my chart. So now when I set up my chart, I set up the DIRT equations up always the same way. Looks like this. And I have the slow person and the fast person. Remember, I don't worry about names because that doesn't matter. I just know that I'm always going to have a slow car and a fast car, slow train and a fast train, whatever. So I have a slow and a fast. And then I have rate, time, and distance. And I flip the order here. D equals RT. And I'm doing RT equals D. It doesn't really matter. And then this one here is total. Sometimes we use the total. Sometimes we do not. Okay, let's go ahead and fill in what we know. So I know my rates. My rate is 15 for the fast. So that goes in the fast rate column. I know 12 for the slow. So that goes in my slow rate column. I know that my slow time is X. And my fast time is X. So now I can figure out how far this one went. This one went figure out what my slow time is, I multiply going across. And you always multiply across. So you multiply across. Alright? So, to fill in that column then, it's going to be 12 times x, which is 12x. And remember, we always put the variable, the box with the variable, in the parentheses. I would never put the 12 in parentheses, I always put the x in the parentheses. And then multiplying across again, I get 15 times x. Okay, so these are the distances. This is the slow distance from here to here, and this is the fast distance from here to here. But if I'm trying to find the point where they would be equal, so this one is equal to that one, this one is equal to that one, in order for me to do that, I got to give the slow person a head start. And the head start I need to give them is an 18-kilometer head start. So that 18 kilometers is a distance head start. So if I want this one to be that one, if I want these two people to be in the same exact spot at the same exact time, I have to give that one a head start. So then I add to it the head start that they would need, which would be plus 18. And now I have this distance, this line. If I add this plus the green here, is now going to be the same length as that purple line. So that means this distance is equal to this distance, and I can now set up a equal value method, or we were calling it equal distance method problem. So I have 12x plus 18 is equal to 15x. And then, to solve this, I'm going to subtract 12x from both sides. And I'm left with 18 equals 3x. And my last step is going to be to divide both sides by 3. So x is equal to 6. 6 what? 6 hours. Oh, there it is. There's the warning bell. See if I can get this next one done before class starts. So x equals 6 hours. So in 6 hours, Kelly will be 18 kilometers ahead of Jack. There's my solution. So this one I didn't need my total down there. Okay, now let's take a look at the adding money and number problem. It's like number 70 from your classwork just last night, or from your homework last night. So that one, we were selling some t-shirts. They were $12. We were selling some shorts. They were $15. We sold a total of 77 items. The total amount that was raised was $780. And they want to know how many of each type we collected, or how many we sold.
Melinda, Para, please report to the office. Melinda, Para, and Julia Gandelas, report to the office, please.
So for money and number charts, I set it up the same way. And I have, this time, I don't have a slow and a fast. I have a cheap and a expensive. So I'm going to write cheap and expensive. That way I'm not looking back going, which one is t-shirts, whatever. So cheap and expensive. And then I have money, number, and total. And down here I have total. Okay. So now as I look at this, the problem tells me that I have, the cheap thing cost me $12. So the cheap money per item is $12. And the expensive one per item is $15. Okay? And they don't tell me like an average per item. So this I'm not filling in.
Also, Melinda, Para, and Julia Gandelas to the office.
The next thing they tell me is that they want to know how many, they want to know how many of each item they tell me. They don't tell me about, do I have twice as many or something like that of each item. So, since they don't give me any information about the number of items that I have to put in variables. So that's an X. Now, the most common mistake people made is they made this one X as well. You can only have the same variable in here if both amounts are the same. If they say you sold the same number of shirts as shorts, then they're both X's. They didn't tell me that. So then I cannot put an X in there. I have to put a Y. Okay, so if they don't tell me, then I have to put in y. But what they did tell me is they told me that I had 77 total items sold. So here's the number of items sold, and there's my total. So right here is 77. All right, and the last thing I do is fill out my chart going across. So I have multiply going across, just like on the other charts. In fact, all charts are the same. Multiply across. So here I have 12 times x, so that's 12x. Again, putting my variable in my parentheses. Here I have 15 times y, so that's 15y with my variable in my parentheses. And the only thing I don't know is this number right here. So I go back and look at the problem. It says I had a total of $780 collected. A lot of students think that since that's money, it goes here, and that makes sense because it's total money. But this is total money per item. They didn't tell me per item I made $700. It has $80. They said the total amount collected was $780. So that is a total amount. So this would be 780. Okay. Once I have my chart filled out, I'm just about done. So to fill in my chart, I multiply going across. Once my chart's filled out, then I add going down. So I add going down. Oh, didn't make it. So I add going down. So I have here is x plus y equals 77. This one right here. Any place that I have a variable and numbers in the columns, I can add them together. And then I also have 12x plus 15y equals 780. And that was this column right here. So it's this column plus this column equals that one. And so there's my two equations. At this point,
Savannah Garcia,
you have several.
Julia Candela, Melinda Parra to the office. Savannah Garcia, Melinda Parra, Julia Candela to the office.
At this point, you have several different ways to solve it. We have lots of methods. We set up a system of equations. So we have two variables and two equations. So we have the elimination method, equal values method, substitution method, and graphing. I'm going to allow you to decide which one you would like to do, but those are your two equations. The way I look at it is you can get from the word problem to the chart to right here. Probably most of you can solve the problem. It's just a matter of can we get to that point. So that's two examples of word problems, one being a third equation. I'll do more third equations in the future. Here's a money and number problem. It works with lots of different types of problems as well. Okay, see you guys tomorrow.